In this demonstration, we're going to take a look at how to use class scope within our classes. For this particular demo, we have a person class, so our person header file shows that we have our 3 private member variables for first, last, and age. We also have our 3 constructors and our destructor. But we've also added some setters and getters, and then we have our say hello function, and these are all public functions, which means that they are accessible outside of the class. When we create our classes in the sample code, we'll see that we call a couple of these functions and how they actually behave based on the class that we are calling, or the class that we're using. We also have the dog class, and the dog class looks pretty much identical to our person class. We have the 3 private member variables, 3 constructors, a destructor, setters, getters, and another public function called say hello. Now the reason that we're showing you that the dog class and the person class are the same in structure is because we have function names that are identical in each one of the class files. This is a part of what we talked about in the theory for this portion, where we talked about the class scope, meaning that we can use the same names for variables and for functions within different classes and not have the compiler get confused as to which one we are referring to. It will be basically inferred by the class that we are using, so the compiler will know which one of these functions we are actually calling. So let's go ahead and take a look at our little driver program here. We have class_scope.cpp. We are bringing in the person and dog header files so that our main class here, or our main method, knows about these 2 classes. And in our first line here, we are creating a new person variable using a pointer called p, and we are using the constructor that accepts a first and last name. Then what we will do is we will output a statement to the console window by using the getFirstName to pull the first name that we have assigned from that person object. Then we will call the sayHello function on that person object. Once we've completed that, we'll then create a new dog object pointed at by the variable d, and we will use the same constructor, the 2-valued constructor, but you'll notice we have a different first name for our dog than we did for the person. Then we will do the same thing again. We will output the dog's first name by calling the getFirstName function, and then we will ask the dog to say hello. And again, the whole purpose behind this is just to realize and recognize that we are using function names that are identical, so the exact same function name in each one of these calls, but because of class scope, the compiler will know exactly which ones we are referring to. So let's go ahead and run this code and see what happens. You'll notice in our first line here in the console window, the person's first name was equal to Tom, and indeed that is what we set for the person's first name here. The sayHello function output the word hello to the screen. Then we've created the dog object, and we've set the dog's first name. I will move this console window just up here a bit, and we'll see that the dog's first name was Fido, and we see that when we output what the dog's first name was, indeed it was Fido. And then when we called to say hello, woof was printed rather than hello. So again, focusing on the implementation details in the person class, we had the getFirstName, which would return this first name, so the first name for that specific instance. But also in our sayHello function, we are simply outputting to the console hello. In the dog implementation, we still had the getFirstName using the this keyword, but we also had a sayHello function, and in this case it simply said woof in the implementation. So again, it's just a quick demonstration to show you how class scope plays into calling classes with functions that have the same names, or even dealing with functions that have the same member variables. Again, the class scope means that those member variables and functions are hidden inside the class in terms of the compiler knowing which one to call. So they're not technically hidden because they're public, but when you call a function on a class, the scope is based on the class name or the object that it's pointing to when the compiler looks for which function it is to call.